the Ancash Team. You see a picture, photo of everyone. Our current location, our goals, what we're trying to accomplish as a team, some of the obstacles that we've had in the last week or so, and then show you our trip from Maracaya to Payawan Changan, and then show you engineering findings of the road, retainage walls, stairs, and then what we'll do is I'm going to turn it over to Gerardo, and he's going to walk you around this site and show you the Chaski Wasi. And then I'll talk a little bit about a road section that's not far from here, and then we'll wrap up. So going to the next slide, here's a picture of our team that we took a few days ago going over a pass, and you can see all the names of people and their affiliations. Going to the next slide, as far as our goals, as I mentioned earlier, we want to try to better understand how the Incas designed and built this tremendous road system that we see as we walk it, and it's really interesting. And we want to try to apply some of the techniques that the Incas used related to sustainability, working with nature and things like that, to our modern day construction. And the other goal is that we want to make our findings accessible to you all through what we call teleengineering. So through telepresence, we're able to bring you, not physically, but virtually, to the Inka Road. So you can see basically what we're seeing and in real time, and you can ask us questions. If you want to see something close up, we can zoom in or zoom out. So we're really excited about this opportunity to bring the Inka Road to the rest of the world. And as far as obstacles, yes, we've had a few. In fact, the very first day we found out that the truck carrying our animals, which consisted of mules, llamas, and horses, the truck broke down not too far from our location, and they had to basically walk the animals to us, which means we didn't have the animals to do our first day's production, and Basilio, one of our team members, rounded up some animals so we could actually do the broadcast. And during that time, one of the workers fell into a ravine and almost seriously could have been killed, basically. And two of our cartons of food that were brought up into the hills went into the ravine and were lost. Megan also got a rope burn in the process. So there's logistical issues like transporting all the equipment that you see here, the food and the and shelters that we have for 15 people at altitudes of over 4,000 meters, which it's not easy. From my standpoint, I get out of breath really easily, and up here it's pretty cold. We've had some technical issues as well with hardware malfunctions, computers not working, batteries not working properly because they're too cold. Issues with satellite communications, which weren't even our fault because there was a storm in Miami over the teleport hub, which knocked out our communications. We've also had physical obstacles such as, dealing with altitude sickness, daily exertion, just walking and setting up the equipment, analyzing our findings and producing the materials, basically all in one day. Like the PowerPoint presentation that you're seeing right now was created last night, probably about 9 o'clock, and it was emailed out about midnight to people. So anyway, we've had a lot of obstacles, but still, I think our team's in pretty good state of mind, pretty good health, and we're really glad to be here and able to share these findings with you all. So going on to the next slide, just show you how far we've come. The Ancash team has come. We started out in Lima, and maybe Cliff can kind of use the pointer in the Meritech whiteboard software to kind of go up that yellow line there. We've traveled a total of 664 kilometers, and we know that because we've got a GPS unit that Andrew is using. So definitely, most of this travel in here was by bus, and then four-wheel drive vehicles, which were necessary to go over some of the pretty rough road, and then the hiking as well. Our current location, yesterday we were in Maracaya. This is next slide, current location. We walked 7.2 kilometers through these mountains. 17.2 kilometers doesn't sound like a lot, but you know, for us it's a lot. It takes us basically about 4 or 5 hours to do that hike. And the Commodores who are carrying all of our food and equipment and whatnot basically can do that hike in about, Megan, 2 hours?
About an hour.
About an hour. So it's kind of embarrassing. Anyway, we got to our campsite late in the afternoon, and the Commodores had already set up our tents for us, which was really nice. We call this 5-star camping because they help us set up. They set up the tents for us. They cook our meals, and it's really nice. So here's a good shot of the area that we're in, with the lake in front. And going on to the next slide, this just shows you altitudes, our altitude difference from where we started in Lima to, you know, where we are now in Payawangachongan. And this will be our highest altitude that we will have on this trip, and it's, you can see, 43, 41 meters, so we're up there pretty high. Going on to the next slide, we thought it would be interesting to share some findings related to the slope of the roads that we're walking and what the Inka, you know, how the Inka designed their road system. And you know, it's really what we found basically is, and as you can see on this slide, the slope varies on their road from anywhere from maybe 5 degrees or so on the low side to 11 degrees on the high side. And keep in mind, you know, the scale on this graph is not right. Okay, that's not exactly, like, that's not how steep the road is. We'd be climbing up mountains with ropes if that were the case. So basically, what the other engineering team saw also was that the slope of the road was anywhere from about 5 to 8 degrees, and it confirmed what our GPS told us as well. It's a very comfortable walk, and I'll tell you that. We did go off the road at one point because the Inka Road was not really discernible. We didn't really know where it was, so we started just kind of heading up a hill, and it was not an easy climb. But when we got back onto the Inka Road, we knew it because, you know, it was you know, a nice grade. You could walk it and keep walking it at a steady pace and not get exhausted. So moving on to the next slide, let's talk about some of the engineering findings that we discovered on our hike yesterday. So we'll look at roads and drainage, stairs, and retaining walls. So here's an example of a road that's paved, and you know, the thing that the marker that tells us that this is the Inka Road is the fact that there are stone walls on either side of the road. Okay, one of the misconceptions I had about the Inka Road was that it was completely paved. Well, that's not true. There are many parts that are not paved at all, but we know it's the Inka Road because there's walls on both sides. Okay, the reason they put stones in certain places is because they wanted to deal with the water issue. Water is a problem up here. They get a lot of it, and they have to put stones down where they know there's lots of water that's going to be crossing the road at that point. So moving on to the next slide, this shows a picture of a road, and this was really interesting because there was a lot of water coming off of this part of the road. Because of that, the Inka engineers designed two drainage culverts, if you will.
He changed the slides a little bit later. Okay, now please.
Okay, so I think now you see the slide that we're on. And here the engineering team is looking at the retaining wall. They're looking at there's two channels that divert water from the hill, the slope on the left side, to the other side of the road. And Daniela was kind enough last night to put together a schematic. Oh, sorry, Cliff. Next slide. The next slide shows a schematic of this drainage, this section of the road. And you can see on the right and then on the left, there are stones that are basically perpendicular to the road, and in between the stones there's like a stone channel where the water would be able to be funneled underneath the road and not go over the surface and erode it. One of the things that we found to be very interesting about this particular section of road is that we could actually poke our walking sticks behind the wall and see what was behind this wall. And what we found was essentially backfill material. Okay, it wasn't soil, because soil would have allowed the water to build up, the pressures would have gotten too high, and the wall would have collapsed or blown out. And so what we found was there's granular fill, and what was left behind this section of the wall was maybe small to medium-sized stones. The sand, gravel, and smaller materials seemed like they washed out, but they still had some larger, backfill materials behind the wall. So we knew that they were thinking about properly draining the water from behind the wall to reduce its pressure. And in some parts of the road, actually, we did see blowouts. Lim was kind of. Oh, sorry. Next slide, Cliff. The next slide shows a 3D model that Lim created of one of the drainage culverts in that road section I was just talking about. And so there's a culvert there because there's flat stones that go across the road perpendicular to the road, and underneath those flat stones is a channel where the water will come through. And down below you can see the drainage port that is marked here on the left side. So anyway, that's a 3D model of one of the culverts in the road. Okay, moving on to the next slide. See what we have here. The engineering team also studied the steps that were built into the road, trying to understand any patterns that they could see in terms of the rise, how high the rise was, how far the run was, etc. And they found some interesting findings here. Here's some examples. So if you look at the next slide, these are steps again on the road from Maracaibo to Payo Huanchagan. Here the coordinates are there if you want to pull them up on Google Earth. The width of the road at this point was 11 meters. What's interesting here, what they did was they created a cross section of this particular road, and you can see where the steps are. There's one step kind of all by itself, and then further up, closer to the pass, the steps get closer together. So we're thinking that the step that's kind of by itself down the slope a little bit could have been there to dissipate the energy of the water. It's like a hydraulic jump, if you will, and we've seen many instances of that. And then also up at the top, since it's a steeper grade, they built steps, and you can see the height of the steps kind of varied a little bit from 0.05 meters to 0.15 meters. And also the run of the step kind of varied a little bit, as you see there, 1.6 meters to 3.7 meters. And what we're thinking is, when we looked at it, we realized that the Incas were, using what was there, because there's a lot of just natural stone in place, and so they used it, and that's why, the rise and run wasn't exactly the same, going up the stairs. In another example, if we look at the next slide, it's more constant in terms of the rise and run of the stairs, because in this case they built the stairwell from scratch. And in this slide, you can see that the rise was pretty consistent at around 0.2 to 0.25 meters high, and the run was 0.7 meters. So they built this, they brought stones in and made it the way they wanted it to be exactly. And on the next slide, here's another set of stairs, and you can see again the rise varies a little bit just because of the materials, 0.15 or 0.08 meters up to 0.18 meters, but on average it looks like it's probably around 0.15 meters for the height of the stair. And then the run varied a little bit as well. But what they tried to do essentially is they used the rock that was there, if they could, to make the stairs, and that's why they're not all the same, if you will. So that's a little bit on some of the engineering findings we discovered related to the stairs on the road. And here's some pictures of retaining walls. There were lots of retaining walls on this section of the road. And the engineering team measured the height anywhere from about 0.35 meters to 2.8 meters. And what the question we had always was, how do they make sure the wall, especially on those really tall walls, how do they make sure the wall's not going to just fall over? And so, you know, we tried to look at wall sections to see if they interlock the wall into the road in any way. It was kind of hard to see, but we did find one section. If you look at the next slide, there was one section of wall where you actually can see, and Cliff, you might want to point to that large flat stone that's kind of angling down. We think that what they did was every so many courses of stone in the wall, they would put a large flat stone into kind of perpendicular into the road, and that would help tie or lock the wall into the rest of the road system. So that's speculative right now, but that's what we're thinking. Looking back on that retaining wall with the culvert, we think that the stones they used for the culvert could have also helped lock that particular retaining wall into the rest of the road. Going on to the next slide. Last night was really cool because we had a pretty clear sky, and we were able to see some really neat star formations, and one we wanted to share with you for people, especially that live in the northern hemisphere. You can't see the Southern Cross. We wanted to share that with you on this slide. It was just absolutely gorgeous. And then Lim took a photo on the next slide. And this is a little bit harder to see, but between our satellite dish and our tent, there's the Big Dipper kind of sideways. And you wouldn't see it normally at this angle or orientation in the northern hemisphere. So we wanted to share that with you. And then, let's see, going on to the, oh, sorry. Okay, I think I'm moving too fast. Let me just slow down a little bit and see if anyone has any questions on anything that that this team has found so far. Over.
Smithsonian, do you have any questions?
This Smithsonian, there was a question about how old the road is.
He lost his volume. This cliff, it varies, but it's from 600 years to 450, 500 years. Yeah. As different Incas or different rulers came into power, sometimes they wanted to build their own sections, so they would rebuild sections or build a new section. So the oldest parts would be about 600 years. The newer parts, right before the Spanish got there, would be 500 years.
And you should remember as well that some of these roads are built upon pre-Inca roads, but you know, I think we can say that the Incas perfected or refined the road systems that might have existed before.
Did you have a question? Can I ask you and you'll ask them?
Any other questions before we move on for a live tour of some of the areas around here? What?
This is Sandy at the Smithsonian. I'm wondering if you could tell us if any of the, or are the culverts still functionable? If that's a word. Oh, I didn't say over. You say over.
No sound, Ed.
Okay, all right. Hopefully you've got sound now. Many culverts that we investigated on the road so far look like they're plugged up with soil and stones.
Your sound cut out again.
Okay, I'll try that again. So most of the drainage channels that we have seen on this stretch of the road are not really just working over the road and not going through the channels or the culverts that the Incas designed, and essentially washing out stones and blowing out retaining walls that were built. So yeah, that's the condition we found them in so far. Over.
And I think we should also remember that, you know, in the time of the Incas, there was a tax that every, you know, living person, except for the old and young, had to do. So the roads were repaired regularly. And up here, you know, this road is not used too much, except for animals and a few shepherds that come up here. So the roads are not moreover, you know, are suffering from the animal use that travels over them.
I might add, this is Cliff again. The sections we were on last year were between villages, and so the people maintained the road, and many of the culverts we saw last year, a section of road just south of where they are right now, were maintained because the people still use the roads because it connects the villages.
Yep, that's exactly right. And here, up here, there really aren't any villages situated along the road. Over.
Well, we'll move on to the next part of our presentation, and we're going to do a live broadcast of a Chasqui Wasi, which is going to be explained to you briefly, as well as a road section. And at this point, I'm going to turn the presentation over to Gerardo Chang, who's going to talk about the Chasqui Wasi. Cliff, you need to change the PowerPoint slide to the next, advance the PowerPoint to the next slide, please.
Next one.
Okay, yeah, that's good. Thanks a lot, Cliff.
Okay, just before I turn over to Gerardo, I just want to explain what a Chasqui Wasi is. A Chasqui is one of the runners of the Inca Empire that would run, well, the distance is debatable, to send messages. There's the famous story of the Chasquis that would run from the coast to Cusco with fresh fish in a matter of days or a day or two. And where we are located here, there is a potential Chasqui Wasi that Gerardo is going to explain to us.
First, let me share with you a model that was prepared for Professor Lin using SketchUp for Google. We can see there the longitude, the length of the Chasqui Wasi is 15.70 meters and the width 7.15 meters. We can find we find some of the world fall, so we can say without doubt is that the height of the world is at least 2.6 meters. Also, because of that, we can find the openings of this structure. Only we can confirm that the door is in this side, the west side of the building. This is the east side, the west side, the south, and the north side of the wall of this structure.
Okay, shall we? So now we're going to go to the actual building. And of what remains, and now we are walking to the Chasqui Wasi. We're going to walk around the south side of the building. These are the walls that remain.
That's a good shot of the wall. Can you get Geraldo to talk about the 3 layers of the wall, please?
Okay, first we measure the dimension of the width of this north, the west side of the wall. The width was 0.9 meters. Also, the east side and the north side, and the south side and the north side. So all the outside wall has a width of 0.9 meters. Also, you can see in the corner that there are interlocking between both walls. Let me show you another thing. Possible to confirm that the wall has a reduction in the width at the top. There, the dimension that we measure at the top is very similar on the base. And also you can see in this the typical three-layer wall. Two outside layers made of stone, and an inner layer made with earth and a little stones. The inner part.
Lost audio.
Well, okay.
This shows you to help us to understand the three-layer wall. You can look here, the first layer, and the other part, the other layer, and this is the inner part that was filled with earth and a little stones. You can get with this kind of construction two well-defined surface in the inner space, in the inner side surface and the other side. Look, so you don't have to no tienes que preocuparte. We don't have to worry about the weight or the shape of the inner part of this first layer. Another thing we can find in this structure is that this inner wall is a little bit narrow. His measure is about 0.6 meters. If you see in this corner, it will appear that there is no interlocking between these two walls. The same we can confirm in the other corner. We don't make sure is this, was an inner wall, but it was, let's see, it was fall down and there is no interlocking also.
Preguntas.
There are some questions?
Preguntas? Questions, Smithsonian?
This is Sandy. We'd like to know whether you see any stones there that have been worked or shaped, and if so, do you think
We lost your audio at the Smithsonian.
Geraldo was explaining about the wall.
Yeah, can you hear me now?
There's an outside layer, an inner layer. By doing that, they didn't have to work the stone but on one side. The other thing, Geraldo has looked at other buildings around and other walls, and we almost believe it's a seismic feature. By having the earth or something in between the two layers of stone, it creates a dampening effect. You got to realize that in Peru and Chile, through this part of the Andes, you get about 10,000 earthquakes a year. They're all not great big ones, but you get a lot of shaking. and they knew how to build a wall, whether it's for a structure or for a house, that would withstand those earthquakes. And so you're still seeing these ruins 600 years later after they were built.
This is Sandy again at Smithsonian. I'm wondering if you have a theory about whether those stones were brought in already worked, or were they stones from the area? Did they wait till they made a place for the Chaskiwasa and then go and get the stones, or did they bring them to the site? Do you have a theory on that?
On our route yesterday, we could see in the hills where it looked like the Incas used that part of the mountain as a quarry for bringing materials for the road and for structures. We also, and I didn't show you this picture in our PowerPoint presentation, but we saw where there were like collection points of stones. It wasn't the quarry, but it was like a stockpile of various sized stones. You know, small ones, medium-sized ones, and some of the large stones. So, and we were also told that you know, the Incas would have to sometimes carry stones long distances to get them to certain locations if a quarry point was not close by. Where these stones came from, I don't really know. I don't know if Gerardo has any thoughts, but we do know that the Incas were well capable of carrying large stones long distances with a couple different techniques that Basilio was telling us about. One was basically like human beings, maybe 4 people, 2 people on each side carrying a pole with the big stone lashed to the pole, to the 2 poles in the middle. That was one approach. The other approach that Basilio told us about was using logs to roll the big stones on. And the logs they used were really hardwood logs they harvested from the Amazon region that they also used for excavation, because the wood was so hard they could excavate you know, the road out, you know, where they had cuts to do or fills. They would use that hardwood to do that. So I'm not sure if I answered your question, Sandy. I just kind of filled in a little bit, but hopefully that helped. I'm not sure if Gerardo wants to add to what I just said.
I said for geologists that Cordillera de los Andes is a very young mountain. You can see in front of this rock, fragmented rock. So Inka Road perhaps was using this kind of rock, fragmented rock from the Cordillera. So you can see anywhere this kind of formation of rock. I forget to mention something that could be good to say now. Perhaps the lack of interlocking between the walls means that the outer wall was
Lost audio.
Audio. Can you repeat the exterior walls?
what?
Okay.
Repeat.
Repeat.
About the
Exterior wall.
okay. Something that we can observe about the lack of interlocking between the inner walls to the outside wall could be means that the outside walls was building first and then the inner walls
Built later.
Mhm.
Yeah. Okay.
Over.
or
Smithsonian Institute, Cliff, or anybody else online?
Yes,
Okay, we're good.
We have a internal question. I don't know where it actually came from. It was on someone's phone. The question is, did you find any surface material inside the structure? And I have no idea what I'm talking about.
Material inside the structure?
What were the
We don't-
floors like?
we don't-
I think is the question. What were the floors of these structures like?
So we can just kind of pan. Let's do a pan of the floor of the structure. You can kind of see.
I don't think you can really identify that just by looking at it. It would have to be excavated. to know.
Yeah.
Yeah. We are
We
strictly
really know.
an engineering team, and we do not have any permissions from the government of Peru to do any kind of excavation. We cannot disturb anything. We can measure, but we can't disturb.
Other questions? Okay. Well, let's move on to the road section, and we'll talk about that.
Just while we're walking, I'm just going to explain a little bit the meaning of Paya Huanchancan, which is where we are located. Paya means the princess of the Inca, and Huanchancan means the place where one gives birth. So legend has it that here is where one of the Inca princesses gave birth. And in the structure behind us, whether it's a Chasquihuazi or not, there is a similar structure up the hill, up the road, just from here, slightly smaller, but also quite impressive. And I'm just going to click into here and have a look at the road. Okay.
So the engineering team, first of all, you can see the size of the road. We've got three the engineering team members standing on the road right now. This particular section of road has a slope of 11 degrees. The width is 9 meters. And what we found to be interesting here was there are 3 steps. And maybe one of those was a drainage channel across the road. We're not really sure, but we think there are 3 steps on that section of the road, which I think, as Cliff had mentioned before, were probably used to dissipate the energy of the water so as not to destroy the road. On either side of this road, there are drainage channels. They're kind of hard to see because the road is not really in the best of shape, especially as you go higher up. Probably the best section of the road is lower, where you see Chris in the orange jacket there. That's a pretty good section of that road. Either side of the road, the engineering team did some measurements and found a channel about 0.8 meters wide on both sides to get the water to drain around the road. This is also the road that leads up to our camp, which was just beyond that ridge there. So that's pretty much all I had on this road. Are there any questions? Over.
Any questions? No questions from us. Ed, go ahead.
Do is Megan is giving you kind of an overview of the road, but with our camera we can actually zoom in. I mentioned that there were 3 steps, and I think with our camera she can zoom in and show you exactly what these hydraulic jumps look like in the road. Over.
That's a step right there that Maria's standing on. It's a, I don't know what y'all say, 0.8 meters. It's a small dimension, but it causes the water to lose energy. So even though the water runs down the road, it doesn't destroy it. We had a show yesterday of the Spanish-built road in the Cusco area, and it was very rutted because the water had cut ruts in it. The Inka Road has not been destroyed that way because they dissipated the energy of the water. Over.
Yeah. Okay, thank you, Cliff. Over. Are there any other questions from the Smithsonian Institute or others out there? Over.
No questions from us, Ed.
What we wanted, let's see, is another member of our team joined us after we did the initial introductions. A really important member of the team who helps with the logistics. and make sure that all the food and all the equipment gets to the right place at the right time. And so anyway, we want to introduce Basilio right over here just briefly. And maybe he can just introduce himself, his name, and you know, what he does for a living. Over. Okay, come closer. Okay.
Buenas tardes con todos están presentes. Estamos en el lugar denominado Payahuachangán, a 3.000 metros, 4.000 metros, 300 aproximadamente sobre el nivel del mar. Es un lugar, Payahuachangán.
Okay, I just want to welcome you to Payahuachangán. We're here at 4,330 meters.
Ya, y como muchos arqueólogos también determinan Chasquihuay, pero primero quiero explicar algo de Payahuachangán. Aquí dio luz a una de las payas del Inca.
Okay, a lot of archaeologists believe that this was a Chasquihuasi, but I want to talk about the idea that one of the Incan princesses or queens gave birth here.
Pero no se sabe exactamente la exactitud de cuál de las incas fue la paya, y tampoco no se sabe salió de Cusco o de Ecuador, ¿no? La paya embarazada, pero se sabe que aquí agarró el dolor del parto y dio luz a la nusta o la paya del Inca.
We don't know which direction the empress was coming from Cusco or from Ecuador, but we do know that she gave birth here.
Bueno, eso un poquito es de acuerdo a las informaciones de las personas o del hombre andino que vive en este sitio o cerca de esta zona arqueológica, y también de la información de muchas personas que transitan todavía este camino para intercomunicarse de la provincia de Huari a la provincia de Carlos Fermín Fiscaral y hasta más allá de Pomabamba, Piscobamba. Bueno, entonces este camino todavía está utilizado por el hombre andino actual.
This road is still used by local people today as an important commerce road, and I have on very good information that this is the birthplace of one of the Incas.
Bueno, muchísimas gracias. Eso un poquito les transmito de este lugar, un sitio muy hermoso del camino Inca de esta zona. Prácticamente estamos al paralelo de la Cordillera Blanca. Muchísimas gracias.
Thank you very much. I hope you've enjoyed this transmission from the Cordillera Blanca.
I just want to add something too that obviously is a little bit more difficult to prove, but what Basilio was saying about the importance of this place as the location where one of the Payas gave birth. When you look at the monumentality of the road, just in this section, as it crosses here in front and then goes straight up with these 3 stairs. Above that hill, there's another huge long stretch that crosses a causeway, maintaining its same width before it goes over the pass. You do feel that it is a sacred place with the Cordillera in front. And so, you know, I think that's also part of what Inca roads are and what the Capacñan is.
Great.
That was Megan speaking.
Well,
Megan
you know,
has walked the entire road from Quito to Santiago, Chile, about 3,000 miles.
That's right, Cliff.
Yeah, you know, as we were going through this broadcast, it looked like it's starting to snow or sleet or something. It's darn cold up here right now. But we're wondering if anybody has any questions. It doesn't necessarily have to be an engineering related question, just about, you know, our life, you know, how we spend our time up here, foods we eat, things like that.
What are
any
you
other
eating,
questions
Eric?
that you might. What's that?
What are you eating for breakfast and for lunch and for supper?
That was my question.
Well, you're going to be surprised with this answer, Cliff. Last summer when we hiked the Inka Road as a group, as you know, the answer to that question was the same. It was papa sopa. It was potato soup. That's pretty much what we had for every single meal. And we were kind of thinking that's what we were going to have this time. We're very fortunate to have an outstanding cook with us. Epi is his name. And he's been making some tremendous meals for us this morning. In fact, we had a nice omelet. We've had steak, and cheese sandwiches for lunch. And he prepares little snack bags for us on the trail with chocolate and apples and some other fruit that I don't know.
Granisa.
Granisa.
Granadilla.
Grenadilla. Yeah.
Granadilla.
So actually, once I saw that, I'm going, wow, this is really cool. They set up our tents, they take down our tents, they cook our meals, they even wash the dishes. It's really outstanding. So we're calling this 5-star camping. We can't be in a hotel, but this is pretty close to it.
Show us the burros and the horses. Do you have llamas there with you?
Are there any llamas here?
No, just the horses.
We got the horses here.
The llamas carry our personal backpacks because they're not too heavy, so they've already left.
Over here, how they camaderos, is that how you pronounce them?
Arrieros.
The arrieros pack all of our equipment. They basically find items that are similar weight. They tie them together, as you see right here. Take 2 items that have about the same weight on each side, then they'll put that on top of one of the mules. The mules carry the heavy equipment, and the llamas carry the lighter, the backpacks and lighter equipment. The mules also carry, all the cooking gear. And we have a video clip, which we weren't able to send you, unfortunately, that showed the whole parade or troop of llamas and mules and horses walking by us up to our camps. It's kind of humorous, but we'll try to get that video clip out to you later on. Over.
Ed, where is your next destination, and how long is it going to take you to get there?
To answer that question, I'm gonna turn the camera to Megan.
Our next location is probably about 7 kilometers from here. We're going to stay up on the ridge for a while before we cross a small pass called Puakhirka. And then we're going to start our descent back down the valley. And we'll be camping hopefully near a section of stairs and pavement with canals just before we reach a place called Cuchitambo. So that is our next location. It should be about 2 to 3 hours to get there, depending on how much we stop and what kind of measurements we take along the way.
What's your elevation going to be tomorrow?
Question, lower.
Wonderful.
Lower. It'll still be pretty high. I mean, I think we'll be at 3,800, maybe 3,900, over.
Any questions? Yeah. Okay.
Megan, this is Sandy at the Smithsonian. A last couple of questions. Hi. And one is, well, just as a comment, this is so wonderful what's happening. We're seeing things clearly. We love what the PowerPoint is really going well here. We have a question about people passing on the road. We don't see any locals. Do they use this road at all? And if you have seen anyone pass, the question was, where were they going? What were they doing there? And might you tell us quickly about this place as a possible World Heritage Site, if it's not already one? It's over.
Thanks, Andy, and hi. It's nice to hear your voice. And thanks for all the comments. We're great that the transmissions are going smoothly. As far as the road is concerned, there are people that use the road. I think that it depends on the season, which will determine the amount of traffic. We have seen several different types of groups. We've seen people come up with their animals. There's a lot of grazing going on in the high plains. That's basically what it's used for. So when we left the first day Tambo, we were kind of with different groups of people, some moving their animals. We met another group that were going up to plant potatoes just before reaching the high Puna. Yesterday, we met a woman with 3 horses. She was by herself. She was crossing over from a small village. I don't even know if you call it a village, a hamlet, and she was crossing the road to go to San Luis to visit her children that were living there. And so she was kind of making a shortcut across the road to get there, and that would have taken her about 1 day to do that. In terms of UNESCO and the World Heritage Site, or making the Kapakniana World Heritage site, it's a very slow process. It's still going on as far as I know. You know, they keep saying that it's going to happen in 2011, 2012. It's a very long and complicated process because it involves 6 countries. It also involves the road crossing sites that are already nominated as World Heritage Sites. So it is just a very long and political process, but it is advancing. And as far as I know, if you can check it on Facebook, there are several pages that kind of are devoted to this. So hopefully, you know, it will be put on that list sooner rather than later. Over.
Thanks, Megan. That was a good explanation. No more questions from here. Yep. Maybe one more question. Yeah. Go. Yeah.
After your question, I want to add a part to Megan's thing.
Good question.
How this project got started is the American Society of Civil Engineers went to Peru about 4 years ago and dedicated Machu Picchu and Tipon, which are down in the Cusco area, as international civil engineering landmarks, and put plaques up at both of those locations. But as Megan said, the road itself, 3,000 miles plus, or if you took all the connecting roads, you may have 25,000 miles of road. It involves 6 different countries, Ecuador, Peru, Bolivia, Argentina, Chile. That's a long process to get all that approved.
Megan, we have a question. What's the cross-section? How does it compare the Inka Road to the Roman roads? Maybe that's a question for Cliff or Ed.
I know a little bit.
Okay.
I mean, I know a little bit. I mean, in terms of the actual construction, that's probably a better question for the engineers. But I mean, we have to remember that the Inca roads, they were made for people and llamas. So you know, there wasn't the need to make these long switchbacks for the wheel. Also, the weight that the road could sustain would be quite different compared to the Roman roads and the Inca roads. And maybe Ed can add something to that.
I'll just add a little bit to that. You know, when I visited Rome several years ago, we did get to walk on, you know, part of what was called the Appian Way. So it's the Roman highway system. And that road system, it seemed from the questions that I asked people, it was built more durably for heavier traffic. It appeared that there was like a sub base or maybe a base under that before you got the top coarse layer of stone on it. So it was the Roman roads were clearly built for heavier traffic than the Inca roads. And in the ground penetrating radar that this group did last, we found that essentially there's no sub base under. It's just the one layer of stone, and that's it. The Roman roads, the Appian Way, it was built, for heavier traffic, had the sub base to it, etc. That's really all I can say. Over.
Thank you. Answered the question.
We just before we leave, we're traveling again today. Oh no. Oh no no no. Oh no, sorry. we're going to be signing off. We thought we would be doing a small offering, but actually we're going to be doing that before we go over the last pass. So hopefully we'll have a safe trip until then, and the Apus will be with us to give us a safe way.
Is it clear enough to try to get
so-
us out of the mountains with the snow now?
Over.
That's wonderful. That gives you an idea of how high you are. Thank you.
It looks like it's an hour. Our time is up, and we'll be switching over to the Cuzco team for their presentation. I'm getting a what's that?
They haven't been able to come up, Ed.
Okay. Have you heard any word from Chris as to what's going on?
I had a phone call, and she was having problems this morning. We've got 3 sick people down there. One, I think, with altitude. One with a stomach problem.
Okay. Well, I'm sorry to hear that. Are there any other questions? We're kind of coming to the end of our material.
Yeah, you got a long walk, man.
Walk this afternoon. We're going to set up our satellite equipment tonight as well. I guess we're gonna be signing off, and again, it's just great to be able to bring, this experience to you. It's been wonderful coming up here. It's not easy. It's a hard location to get to. So through this notion of teleengineering, we're just glad we're able to share it with you. And it was nice also, Cliff, for you to kind of come in as an expert and provide some explanations to us. Also another notion of teleengineering. So anyway, thank you, and I guess we're going to sign off as the Ancash team. So goodbye.
Thank you very much, Ed. It was a great presentation. We're just waiting for a second group to come online. They're coming in from Cusco. This group is coming in from Team 2, and if you were here earlier, their elevation is 4,200 meters high. It's about the highest point that they're going on this trip right now. And as I said, it's really cold there. There's power sleep. And they're about an hour behind our time right now. This is all live.
Well, first, welcome to the National Museum of the American Indian. We're so pleased you were curious enough to come in and see what we were up to. This is a really wonderful experiment we're doing. For our long-range plan is to be able to incorporate this kind of long-distance, real-time discussion with researchers, archaeologists, curators who are in the field, and give you a chance to see what their research is like. Our big goal is to open a major exhibition, probably one of the biggest we've ever done, called the Kapakyan, which is the Inka Road, also called the Royal Road. We intend to have it up hopefully in 2014 or 15. And this process, as you can well imagine, the technology will be flying ahead of us. So we might be able to use the entire auditorium downstairs to do this sort of thing for a much larger crowd. I just wanted to tell you a bit. Has anyone here ever been to South America? And Peru? You've been to Peru? You haven't been to Peru. Well, we're doing a whole lot of research on this area, and some simple and important and basic things about what's happening there, at least from our research, is, a basic knowledge is that the Inca, the empire itself was very short-lived before the Spanish came. They had been at war with each other, and the entire life of the empire wasn't much over 100 years. Before them, the history of other nations in Peru, other indigenous peoples in groups, was thousands and thousands of years old.
See your picture, Tim. You ready to come up?
Some of the coastal people down in Paracas were
Tim.
2,000 and 3,000 BC. They had maritime networks. They were trading on reed boats that were going from southern Peru
Tim,
and
Ancash
some of the
Team
northern
just signed
Peru,
off.
all the way
We're
to
ready when you are.
Mexico, the west coast of Mexico, bringing back metal objects and
Cliff,
some
it looks like they
foodstuffs.
disconnected. We're just
can we turn them
looking
down
at a frozen picture of their last transmission.
Yeah, that's really their first transmission, but okay.
I'm going to ruin it for you.
I mean, I think we did real good with that
Another
last
bit,
one.
a little bit of knowledge about this area.
up there high, it's cold today.
The
They've had snow.
people in all of South America, and of course mostly the coastal people, were geniuses in many, many ways. They had perfected the use of metals, melting points, mixing metals, filigree, lost wax. They were able to, without, and remember, this is without the written word. No actual paper documents. The Maya, in fact, are the only ones that we know of who had codes and glyphs to at least communicate through the centuries. But we're going to be studying a lot of about also the cultures that were before the Inca, keeping in mind that this road was perfected by the Inca, whereas the cultures before the Inca had in themselves, right after 10, 30, 300, maybe 300 AD, had very complex road systems of their own. They had irrigation canals. They had terrace farming. They understood the different levels that were in Peru, from the dry coast up to the highlands.
Welcome back.
There were amazing things going on before the advent of the family of the Inca. Which was a very small family who married only within their family.
This is the Cusco team.
And then, of course, their power. They had the power to take over, either by agreement or war, all of the areas, all the way down through Chile, and then take over the Inka Road, the pieces of the road that went into their countries, and unify it. And then on top of that road, manage all of that, keeping surplus materials, moving soldiers back and forth, moving messages back and forth, storage in almost refrigerator-like kinds of storage.
Okay, I just wanted to let you know
So
that
it was
the
quite a
presentation is
sophisticated
already
thing
in the whiteboard.
until the Spanish came.
You to proceed.
And they were
If,
warring
I
among
might help
themselves,
you,
so it's one of those
pass the
classic
slides if you
things.
want him
They came in
to.
during a week
And, this museum is
time,
also
and they
where,
took over the
no
last
audio
Inca out of
right now,
Hualpa,
but
at a place
everybody
called
is on the-
Cajamarca, and then it was all downhill from there for the Inca.
I mean, I cannot
Some of the
hear
Inca
you at
remained.
all.
They married into the
We're
Spanish, and there are
very
people still
bad
who can
internet
claim
connection here
the
today.
heritage.
It's very, very cloudy, and it's raining,
we in?
and we
Okay.
can't get any a stronger signal. Over.
Well, at least I can right now. I'm gonna write in the chat, okay? So you can.
I hear you good, Chris, and got a good picture. Smile for us, please.
Okay, can everybody else hear me? Smithsonian, can you hear me? Over.
We can hear you. Go ahead.
I've got your PowerPoints on the whiteboard, and I can run it for you. We lost sound.
Loaded, and they moved us out of a, just basically left us on the street. So we hailed 2 cabs very quickly and got here. We carried our equipment pretty far. We have everything set up now. We are broadcasting from the site that you saw, hopefully you can see on the PowerPoint. It is a waka. It's another large waka along our route, and we are at an elevation of 3,668 meters today, and we're working to try and get our camera up and running further down so we can show you around our site. It's a beautiful site. The place where we're actually working today is the first large waka. And what a waka is, for those in the audience that may or may not know what a waka is, it's any place that the Inca considered to be sacred. It has ritual significance. It can be a natural rock, and how we've been able to find our wakas here along our trail is they tend to be natural rock structures that the Inca carved different components into. And so we can see that the stone has been worked. Some things are in a step-like structure, or also we've seen some benches. And when our video camera gets up and running, we'll take you into a waka so you can see some of the offerings. All of the wakas that we've been looking at so far along this route are actually still in use today. And Kevin Florkey, our archaeologist, will be actually discussing this entire waka with you, and you'll see incredible sights. In addition to looking at the wakas, and we'll walk you through those momentarily, our research team has also been looking at several terraces. We have found several Andean terraces, and what Andean terraces are terraces that were meant to support vegetation and agriculture. And we have seen several examples of that along our route. We have on our PowerPoint, one of the slides will show our terraces. And
we're getting pictures now of Jen and them. Can you hear me? We're getting pictures of Jen now.
If they can't adjust it.
Now it's frozen.
Okay, I cannot hear anybody on my side, and according to what's been typed on our whiteboard, it says that our downstream may be choppy for a while. The terraces that you hopefully can see in the PowerPoint slide are above an area that we found that we'll broadcast from tomorrow that looks like it was a natural lagoon, and the water that ran off of these terraces was in this particular area was able to kind of pool and create a lagoon type of a structure, and we'll look at that tomorrow. I'd like to introduce our team. in a moment, and I need to get them up here in order to do that. We're high above where we had planned to broadcast today. So our communications tent is up above the site, and we will go back down there. The problem is that it's pouring down rain right now, so we can't get our other camera up and working quite yet. So if you could bear with me, I'm going to call our team up here so that they can introduce themselves, and hopefully if the rain lets up, we can go down and actually show you our sites. If not, we'll continue to transmit directly here from the tent. So if you could just hold on for a brief moment, I'll call the team up, and while they're coming up, I'll continue to go through our PowerPoint presentation. Over.
Just so you realize, for those people that are in North America, it's summertime here and it's very hot across the United States, but down in South America, it's wintertime. It's exactly the opposite. You've crossed the equator, so a little bit different.
Okay, yes, it may be hot and sunny back in the States, but it's cold and rainy right here now. As you can see up on the PowerPoint slide, you have Jennifer, Edgar, Nicholas, Pedro, and Camilla, and they are part of our engineering team, and each of them will introduce themselves briefly and discuss what they've been measuring that we'll show you in our broadcast today. Okay? Come on in, make sure you can see.
Okay. Hello. My name is Edgar Rodriguez. I am a civil engineer and I work in the University of Piura.
And Edgar, what have you been measuring yesterday that we're going to see in the broadcast today?
Okay, yesterday we have measured the cross section of the Inka Road. It was really hard to measure that because we saw that along the road there was a lot of stones, of rocks in it, and we think that rocks belong to the walls, to the retention walls and the contention walls of that road. So it was a little hard to do it, but we make it possible.
Thank you, Edgar. Yes, they have collected amazing data. We'll be using this information to help verify some of the theories associated with the road. So next on our team, we have Camilla. And Camilla has been working very hard with the measure and engineering team also. I'll let Camilla introduce herself and tell you a little bit about what she's been doing.
Hi, I'm Camila Bessa. I'm studying engineering in the Universidad Católica in Chile. The same as Edgar said, yesterday we were measuring the road that is few documented, and we measured the width, the slope, the grade, and where there were walls, we could measure the walls, and we found several, like maybe evidence of a channel, and
the section of road that we were measuring yesterday, and you'll see this in the PowerPoint presentations, is a road section that has not been investigated very detailedly yet. And so we were led through this site by Donato Amato, who is a local archaeologist who was able to help us interpret the road and where the road went. As Camilla said, it was very difficult to find evidence of intact retention and contention walls, and the difference between a retention wall and a contention wall, and how we were able to tell the difference between the two, was we had for the contention walls, they hold up the road. So if a person was traveling along the road, they would never see that wall. So the stones within that wall tended to be smaller in areas where there was not needed a lot of foundation support, and those stones were not very finely worked. So we were able to tell a contention wall when we saw the stones weren't finally worked, and because nobody was meant to see them. The retention walls were along the road, and they were meant to be seen by the traveler. So those walls tended to have larger stones that were worked and fitted together very well. So we spent most of our day yesterday walking through sections of the road that looked just like a field of stones. And if you see in our PowerPoint, there were just a field of stones that we were looking at, and without Donato's help, we never would have been able to tell that it was actually the road. But we were able to find sections and measure sections, and what we found is that there was a very much a continuous slope to the road, or continuous grade to the road, of about 3%. We measured it in several different locations, and it was very consistent. So we're not exactly sure how they were able to maintain that consistent slope, but they did. So with our retention and contention walls, we spent a lot of time measuring their heights and their width. Some of the things that we found very interesting about those walls is the width of the walls began to change as the elevation of the walls and the road moved higher into the mountain area. I don't know if you can hear the rain coming down.
We can hear the rain coming down. Tell Nicholas to stick his head in because his mother is watching him. Stick his head in, Nicholas.
Yes. We're working to introduce the rest of the team as they come up here. So let me just finish quickly with what we found on the contention walls. Is they got thicker in areas where they actually needed greater strength. And they changed from a width of about, typically we find them at a width of about 60 centimeters. And as we moved up the road where they had to support a greater load, they moved to a width of about 90 centimeters. And the stones actually got larger. So we were able to find different sections of the road and what it was meant to carry and the loads that it was meant to handle. So what I'd like to do now is bring Nicholas in and have him talk to you, introduce himself.
Chris, can you hear us?
About what he... Over?
The control button live.
And introduce yourself. Yeah.
Hi, I'm Nicholas. I'm a high school student from Chile. And
Go ahead, just
I
say what you did yesterday.
yesterday I took pictures of all where the places we were going and studying.
You know we're okay down there?
Okay. Can everybody come? I'm just trying to get everybody introduced up here.
Sure.
Okay.
Okay. They can introduce down there too.
Okay. Next we have Pedro, and Pedro will talk to you about exactly what he did yesterday. And we're ready to go down below, so I'm gonna head down there once Pedro is finished speaking.
Good morning. My name is Pedro Escajadillo. I'm an architect and I am a professor in the Piura University. ¿En Spanish?
Sure.
Yeah. Hola, soy Pedro Escajadillo, soy arquitecto, soy de Piura, Perú y trabajo en la Universidad de Piura como profesor. Over.
We got you, Chris.
Okay, we're back, and hopefully you can hear us. We're down by the Waka now. Unfortunately, for those in the audience, we cannot hear you. So if you ask a question, you'll need to bear with us while Tim yells it down to me from up where we are. So I said that one of the places, things that we visited along this road were wakas, and I said they were spiritually significant places. And the best person on our team to talk about our wakas is Kevin Florkey, and here's Kevin.
Okay, so as Chris was saying, we're broadcasting here today from this waka, which is in close association to the Imar Kahwasi from our previous broadcasts. But for those of you who are just joining us for the first time, I'm going to go ahead and make an attempt to explain the complex concept of wakas in a brief way. For our intents and purposes, essentially a waka is any location or object that is invested with power or significance. Now I'm being particularly vague there on purpose because terms such as religious, sacred, or supernatural are linked with our own cultural connotations, which are removed by 500 years in an entire worldview from the Inca themselves. Now, that being said, the worship of wakas actually extended far back before the implementation of the Inca Empire, and it continues today. I'm going to be taking you around and showing you how it works in just a minute. First, to understand how it is that the Inca might have invested so much manpower and resource into the veneration of these wakas, we have to understand a little bit about the empire itself. Now, the Inca, as many in the audience may know, were the largest empire in the world. They extended all the way north from Ecuador down through Santiago, Chile. Oh. Sorry if you guys are having trouble seeing or hearing me. As you can see, we're having some inclement weather here. So anyway, the Inca Empire extended all the way from Ecuador down to Chile, and it also spanned a time period that was relatively short. So, here, we're going to move this way. It is hailing on us right now, so we're going to try and move to an area that's easier to broadcast from. So, in covering these tens of thousands of kilometers, the Inca Empire would have faced many challenges, such as a very diverse and not culturally or linguistically unified group of people. They covered many ecozones, such as the coast, the desert, the jungle, and the highlands here in the Andes. And so they faced a lot of challenges in integrating this very diverse and widespread community. They implemented a lot of different strategies, such as the widespread relocation of conquered peoples in order to integrate them with local communities, as well as the implementation of a state religion across the entire empire. And perhaps most important to our study here, mandatory pilgrimages to the capital for all high-ranking members around the empire. Now, as I said, this waka is located only a few hundred meters from the primary road to Antisuyu, which we showed in previous podcasts. Antisuyu is in the northeast and extended into the jungle ecozone. So this was a highly contentious and often difficult area to control. That means this valley where we're in now would have been frequented by delegations from every corner of the western half of South America. Now, in understanding that, it becomes a little bit easier to understand why you might invest so much resource, maintenance, and veneration of sites in this area. Now, through our work with local archaeologists who have graciously given us their time and their information, we've actually discovered that the roads in this area serve many more functions than simply carrying travel from point A to point B. In fact, they also integrated these sacred sites, such as the waka that we're at now, as well as demarcating zones of administrative control and zones of production. So with that in mind, when we view it in that light, we can see that a waka such as this actually would have been much more than simply a sacred site, and these roads would have been much more than simply conduits for travelers. A series of messages embedded in the landscape itself. So regardless of your cultural and linguistic background, if the interpreter is human, they're likely to understand a concept such as a road, and they're likely to appreciate something such as a striking jut in the landscape like this huge stone outcropping, which we're huddling under now in order to avoid the rain and the hail. So it's with that in mind, I wanted to show you some of the actual associations with this waka. If we can pan over here through the intense rain and hail, we can see the architecture that would have been associated with the site. It's been excavated by local archaeologists And while interpretation is hard to make on a site like this offhand, it is very likely that would have been used as a staging area for the rites carried out here, and possibly as a storage area for the goods that would have been necessary for the veneration of the site. And if we can come inside here to the cave, I'll show you too that we can see how the waka is still in use today. So, Cami, if you would come here and light it up for me. Hopefully you guys will be able
I don't know.
This is without the button, right, guys?
We have a picture on the screen of coca leaves left as an offering. We like to make sure you know that the coca leaf in South America has some ingredients, and it's made up of there's my phone. Can you turn it off? Of parts of things that it will oxygenate the body. And people who travel might be given coca leaves. You can get them actually at any store. And the Andean people have found a way through chewing these over a period of years to be able to acclimate themselves to incredible heights. It has little to do on the practical side with cocaine. There are many more things that have to be added to the coca for it to ever become cocaine. So what you're seeing, are they back on? What you were seeing is coca as a sacred leaf being offered at the huaca, and including today, up until today, and probably always will be. And what they're showing now, once again, is the terracing. Just a really unbelievable way of farming. The layers of the terraces have plants that actually have been studied by the Andean people for thousands of years, so that the lower ones have that type of climate. Actually, they study them in indentations in the ground to know which level to put which plants, and then irrigation systems. The water falling irrigates the terraced farmland. And what we're seeing there, now here's the coca again, and you can see that the worked stone is amazingly almost perfect. Those are some of the conundra that are out there now. How did the Inca, without any metal tools, work this stone? We don't have that answer, but we're certainly pursuing it through this exhibition. There have been theories all the way from lasered redirection of sunlight to just chipping away, using other stones to chip away and buff away. But you can imagine how many thousands of hours would go into building major structures by hand, each stone. Now there's an example of these enormous rocks being worked by hand. Another thing we're studying are lengths of woven string that are called quipus. There's a lot of study being done now about accounting methods used simply by a series of knots in a string. And quipu, the people, the important people who would keep the quipu were people who did understand them. There are some beautiful ones in museum collections all over the world. There are also scholars who just study where these huacas are, just pinpoint them on maps. And if you were to do that research through Google, through good primary source books, you'd be able to see some of the work that's been done just to locate where these huacas are. And there are more being found and discovered all the time, and then noted by scholars such as these. Does anyone have any thoughts or questions they'd like to ask upcoming or about the history before the Inca? Well, also remember, this is an experiment, and it does stop and go, and you can feel free to come and go into the exhibitions anytime you feel like it. But we're hoping that you'll stick around to see what they're discovering. And here are some beautiful scenes of the road itself. And if you do look at the map, if you have a chance, you can see how this road actually links together these enormous nations from north to south. And the Inca themselves were really incredible empire builders to be able to unify so many countries that were inherently different in their languages, their religions. It's not as if they could go from state to state and visit all the time and see what they were making over there. These were long trips. Each country had crops they could grow in their specific place. And because the coastline of Peru is so incredibly dry, they would have to bring water in, and the trade was very important. So there's a lot of proof now that trade actually was going on far before we thought. And we were also looking at these rocks being brought in. That might include being able to weave baskets and bags that could carry rocks this big along the road.
No, not yet. We still have problems.
For those who just came in, we're talking about Peru, really actually 4 or 5 countries above and below Peru, all that encompass the enormous Inca Road, the Capañan, that was perfected by the Inca Empire in a very short period of time. Now, you probably already know that the Spanish were very interested in South America. Well, they were interested in the entire Western Hemisphere. They were always looking for gold and other precious metals. They weren't very interested in staying. They weren't there to colonize, unlike our northeastern coast. They were really there to discover what they could discover. So they would come upon peoples that some, in case no one had ever seen before. The Spanish did know something about South America. Some trips have been made very early. In fact, the crew that went ahead of Pizarro went through the Panamanian area and saw a raft made of reeds that was a trade raft that was coming out of Ecuador and going probably to the west coast of Mexico. This established an early on idea that there was major trade going on. And that has importance not just because we find interesting objects in countries that are far away.
That contention wall is something that the traveler would not have seen. And if you can look at the stones, they tend to be sort of small. And if we can move to the next slide, I could talk to you a little bit about the retention and contention walls. I think that's the next slide. But those walls pretty much delineated where we measured yesterday when we were looking at the sections of the road that were pretty crumbled. It was honestly very difficult to tell where the road began and ended until we were able to find these sections of walls. When we saw large stones that were well worked, we knew it was a retention wall. And when we were down below and we saw smaller stones that had not been worked, we knew that it was a contention wall. So as this slide comes up and we're waiting, before I ran up the hill, I was discussing an access point to water. And we had thought that originally that a bridge could potentially be there because we found stairs. But we never were able to find any evidence on the other side of the river, or of the stream at this point, of any type of bridge access point. So we went up to the top of the ridge and began to look to see if we could find any access roads to that particular structure, to those stairs. And with a lot of work, Kevin was able to find that there was a road that led off of the main section of the road down to the water. And there was a road above us that actually led down to the, or led up to the Waka. So to kind of go on what Kevin was discussing about how the roads serve different purposes and how they were used to integrate the empire. We also saw that there were many roads that led to different structures that branched off of major road sections, and the only way to move from one section to another was to follow this particular road. So the roads definitely had a particular purpose. So we saw a road that led directly to water, and it did not lead anywhere else. It didn't connect to any other structure or continue to the Waka. You actually had to walk all the way back along the ridge and then hike up to get to the Waka. So the roads were used in many different ways, but very specific ways. And that's something that we had not seen before. Okay, now on my screen, I see an image of a retention wall. And if you look closely, you can see that the road is in a state of disrepair. Thanks, Cliff.
No, the road's below it.
The road is actually below below that wall. So if you go to the left, yes, exactly where you're pointing now, Cliff. And that we know that was a retention wall because of the fact that the stones were bigger. And then below that was the contention wall, and these stones were bigger and finely cut.
That Y is the tooling.
Okay, so you can actually see the tooling that occurred, and these walls were visible to the traveler. So the Inca wanted people to be sure that they saw their fine craftsmanship. Cliff, could you move to the next slide? It takes a while for us to actually load. So while that's loading, are there any questions from the audience? Over?
To us, or you been talking to anybody?
Smithsonian, they're on.
Yeah.
We've got a picture of the steps, water access point below the Waka.
If anybody has any questions, we can talk to them. Yes.
The picture is slide 24, okay. Water access point below a Waka.
This line that is showing now is actually the point that I was discussing. We found this access point with these 5 stairs and this very well-defined wall, and there was a road that actually led directly to that, right at the top. The next slide will actually show the full set of stairs that move up, and you can see a little bit of the small portion of the road. It's very ill-defined because of the foliage and everything that's grown up around it. Kevin, do you have anything to add?
Sure. Yeah,
as you look at that picture in that last slide, you can see that, or in this slide too, you can see that those stairs are very well made and they extend down, but then it's not as though the stairway stops or we've lost the rest of the stairway. There's very clearly a well-made wall that extends below it. This is confusing, essentially, for us as archaeologists, because we wonder, exactly where was this road meant to go. It's not easy to access that bottom stair, and there's no reason to cover up that very finely made wall with any more stairs. And across, there is no level plane on which to receive a bridge. So the best interpretation that we can make at this time is that the level of water that you see below it, which flows freely, and we also have to remember that despite the downpour of rain we see today, this is actually the dry season in Cusco. Yeah. So the rivers and the water levels that we see are as low as they get in this region. So as far as we can tell, there may have been, in the rainy season, some damming just down below that section that would have led to the water being at a higher level, which would have meant that that would have been a convenient water access point. Other than that, any other interpretation of that area seems to be very difficult to make. So that's obviously, without more excavation, we can't say for sure, but
Well, we've lost contact with them right now, so we'll have to see if they get back on again. They're in their they're having a storm there where they're at, a rainstorm in Cusco, so that may be part of the problem.
Wireless. It might have just gotten too rained on. But we're back and we don't know where we actually lost you, so we're wondering if there were any questions for us. Over.
No questions from the Smithsonian right now, but we've got you back on sound and picture. Was there a question?
I'm sorry, Wayne, you didn't come through quite clearly. We heard that there were no questions from the Smithsonian, or there were? Over.
We do have a question. The question was where you are and what are you studying right now and where are you? This is a new, the audience is coming and going a little bit. So if you could kind of back up and just tell us where you are again. Over.
Okay. Your sound wasn't coming through that well, but I think I heard that you wanted to know where we were broadcasting from. And we are on the offshoot road to Antisuyu, which is north of Cusco. We're at an elevation of 3,643 meters. And our broadcast site is actually from a waka that we found along the roadway, and it's actually still in use. Actually, right before we were getting set up for the broadcast, we had some individuals come down and kind of set up in the waka. We were hoping that they would stay while we were broadcasting so you could see it in works, but they had left. We are actually to the north of where we broadcast from the other day, which is Amaro Markawasi, and the area is, there are several roads in the area that we've been looking at. Some of them lead directly to different structures, and some of them will lead to water sources. So we found several things in this area. Overall, the road section in this particular location is very ill-defined, so it hasn't really been studied. We're kind of, other than by archaeologists, it hasn't been excavated either. So that kind of sets where we are. We're north of Cusco, and we're trying to stay dry. This is actually the waka in the sunshine. If you can see the picture up there. That's where we're broadcasting from, and our research team is now huddled underneath a structure far away from here because of the rain and the hail. But we have been, this is our engineering team pictured here, part of them. The next slide will show the rest of our team members. And this is Rudy is a student from the Universidad de Piura, and he has been working primarily on the hydraulic structures. Here's all of our archaeologists, Donato, and then Tim is our expert broadcast person, setting up our satellite systems. But when we're not broadcasting, Tim's out taking notes with us. And then you see Kevin and Tom, all archaeologists that have been helping us out very much throughout this entire trip. Okay. Can you go to the next slide, Cliff?
We got Julie's smile.
There she is.
Introduce yourself.
Oh, that's right. I didn't introduce myself. I'm Chris Fiore. I'm a professor at Virginia Tech, and we're really happy that we've been able to work with the Smithsonian on this project. This is a National Science Foundation funded project, and myself and Ed Jaselskis and Cliff Scheckschneider, who has been so graciously jumping on board and filling in when our broadcasts aren't going so well. The three of us have written a grant to the National Science Foundation, and we've been working for 2 years now documenting the road, and we've been working with these broadcasts and a little bit of tele-engineering to bring our experiences back to you. I don't know how great our experience was, such as they are. Today has been an interesting experience. As soon as we started to broadcast, we got rain and hail, so hopefully you were able to kind of experience some of the rain and hail with us without actually getting wet.
Chris, can you tell us where you're going to be tomorrow and what's going on with the team there in Cusco?
Yes, tomorrow's broadcast, we're going to move further into the valley, and it's something that we have never explored before in terms of our team. Typically, we're looking at the road and different structures, but Donato pointed out to us an area that looks like it was a potential place where there could have been a lagoon. So we've been looking at some structures that we believe were dams, actual dams that would hold back water in an area that was below another Waka structure. And tomorrow we'll broadcast from that lagoon area so that you can actually see the basin that we believe held water. You'll also see several very tall retaining wall structures that are very thick. They were on the order of 2 meters?
6 feet.
So, yeah, about 2 meters wide. So based upon the construction of those, we believe that it could have held back that water. So we'll be showing you around that area tomorrow and some of the sites that are being restored in that area. So you all can see the large area that would have been filled with water. And with a little imagination, you could probably tell how beautiful it was when it was filled with water. Over.
Chris, our time is about up here, and I want to thank everyone for coming online and telling us what you're doing. It was very instructive and really good today. Thank you. Over.
Thank you, Wayne. It was our pleasure. Thanks for bearing with us as we dealt with some of our technical issues. It turned out that because of the clouds, we couldn't get a strong connection, so we couldn't do anything about the clouds today, but everything else we were able to overcome. So we look forward to an excellent broadcast again tomorrow. Thank you.
Thank you, Cliff, for your help. Over.
Okay, can you stay on a minute, Chris?
Sure, Cliff. Over.
The other team got hail and rain 2 days ago. I guess you got it today. Plus, they're freezing to death, all of them. I've never seen them so cold.
Yeah, it's been brutally sunny and hot here for the last like 3 days.
Until about an hour ago.
Yeah, we got here. It was so funny. We got on the bus this morning, and the bus driver basically just said he didn't have time to take us where we needed to go and left us in the middle of the road. But right at that moment, a taxi passed by with a roof rack, because of course we have our satellite dish. So a taxi passed by with a roof rack. Kevin hailed them. We got that taxi, threw all our stuff in there, strapped the satellite dish to the roof.
Grab the gas for the generator.
Grabbed the gas for the generator, and Tim and Jennifer and I got another cab.
I think we're in the sign
and the cab didn't have any gas. So we actually just made it to the gas station.
Okay.
And then we got here, and the only way to get our equipment.
Thank you for visiting. We're going to do this again tomorrow. And we're going to continue to do it till we get it absolutely perfectly right.
Thanks, everyone, for coming. We're going to be doing this again tomorrow at 12:30 Eastern Standard Time, broadcasting from the Ancash area and then Cusco area. Thank you. Almost. There.
Okay. Was that your genius idea to block that pain in the butt side of the screen and put in those?
No, we can do that. It allows us to do that.
We've been asking that for 2 years.
Well, the software does it, but they didn't have the material before to do it.
Oh, so we could have put we could have used it.
Actually, we could have sent it down to, we've been sending it to Newcom down in Miami, and they've been posting it.
See,
but
last year we were stuck with
but we don't know how to do this stuff, so it's like
Well,
we're learning.
This is one of those epiphanies, because that really matters.
It helped a lot, huh?
Yeah.
The Ancash group was great. Ed,
They
Megan,
were really rolling. I mean, that's a perfect experiment.
they really had it together.
Yeah.
Yeah.
Well, they didn't have any, they had no real kids. I mean, the other group was a lot of students, a lot of
Yeah.
high school kids.
But Ed's a very good talker.
Yes, they
Brought it
were
all
smart.
in.
Exactly
Megan
so.
could pick up all the pieces. She knows.
And they remembered some things, and that is if
Uh,
they say a new word, they'd explain it again.
Yeah.
It's very cool.
Yeah.
They,
So it's working.
oh,